All right, so let's jump right in. Today, we're doing a deep dive into something that's, well, pretty foundational for any critical infrastructure. We're talking about power stability.
Mm-hmm.
And we're going to look at it through the lens of one specific piece of tech, the NTI E-ACLM-P18-V2. Our mission here is to really unpack what this thing does, not just read a spec sheet, but understand what proactive power protection actually looks like.
Exactly. It's a great case study because this sensor, it's designed for serious enterprise systems, data centers, server racks.
Right.
So at its core, its main job is to monitor the AC line input voltage and the frequency. It can handle two separate lines at once, basically covering the global standards, 50 to 250 volt AC and so on.
Okay, but just monitoring the basic voltage. I mean, my cheap UPS at home does that, so what makes this so special?
Well, you're right, but this is about power quality. It's not just logging the numbers, it's actively hunting for these subtle threats that can kill equipment slowly. Or worse, cause these weird intermittent data glitches.
You're talking about the things that are really hard to diagnose?
The three silent killers, yeah. We're talking about sags, swells, and spikes.
Okay, break those down for us. A sag is like a brownout.
It's a momentary dip in voltage, yeah, a brownout.
Yeah.
And that can make components draw too much current to try and compensate. A swell is the opposite, a brief surge that really stresses the power supply.
And spikes are just those really fast, damaging hits.
Exactly, like lightning, but on a smaller scale.
The thing that stood out to me was the granularity. It says it can track the duration of a sag or swell down to 0.1 of a second. That seems incredibly fast. Why does that matter?
Because a tenth of a second is an eternity for a modern server. Seriously, imagine a critical database write is happening during that 100 millisecond sag.
The whole transaction could fail.
Or worse, corrupt the entire file. Most systems just average the voltage over a minute and they would completely miss that tiny destructive event. This thing logs the number of events and how long they lasted.
So it helps you find the root cause of those bad luck failures.
Mm-hmm. And speaking of hits, you mentioned spikes. You can actually customize the detection threshold. You can set it to trigger on a peak greater than 50 volts, 250, 500, or even a full kilovolt.
So you can match the protection to how sensitive the equipment is.
You got it. And this model, the P18-V2, it's built tough. It's rated for an 18 amp load, maxes out at 20 in the US, and it can measure surges all the way from 300 milliamps up to 20 amps. It's designed to survive the very things it's monitoring.
Okay, so it's a very detailed analyst, but the part that really elevates it, for me, is its ability to act.
Yeah.
This is where that integrated relay comes in.
That's the strategic advantage right there. We're moving from just passive reporting to active protection.
How did that work in practice?
The relay has configurable settings. So if it detects a really damaging swell, one that goes past a threshold you've defined, it doesn't just send you an email alert.
It does something.
It can automatically trigger an action, like it can force a reboot or even completely disconnect the power to protect the equipment. It's automated, instantaneous defense.
And all this data and control links back to the central ENVIROMUX system, right, over a standard network cable.
Yeah, CT5 or 6 cable using the RS-485 protocol. That gives you a solid 1,000 feet of distance, which is, fine for a typical data center.
But what if you're talking about something huge like an industrial park or a big campus?
That's where it gets really impressive. You can add this fiber converter, the EFSC, and suddenly you can push that distance up to 1.2 miles. That's 2 kilometers.
Wow.
Think about it. You can put these highly sensitive, actively protected monitors all across a massive logistics center or down a long utility tunnel and never lose control or signal.
So to wrap this up, what this really means for you, the person managing this infrastructure, is that this isn't just a monitor. It's a proactive defender.
It detects those micro events other systems would miss. It gives you immediate automated action through that relay, and it offers this massive scale for coverage.
Which leaves us with a final thought for you to chew on.
Yeah, and it's an important one. How much more value do you get from being able to define your own minimum and maximum power thresholds to set your own safety margins, compared to just waiting for a catastrophic failure to happen?
It's the difference between defining the rules of the game and just reacting when you've already lost.